Okay, so hello everyone. We are going to deal with new subjects. I'm going to share with you integral. So here we are. Okay. So today we are going to talk about integral, and the whole of this chapter is talking about integral and application of integral, how to deal with it, how to find it, how about area, everything that we need you can find here. So I'm going to start recording the screen here. Maybe later you will get some benefit from it. Now you can see here I have an integral, the definition and the history. So I will give you a little bit background, a little bit history about the integral, and later I'm going to the deep of that subject that we need. So generally we can see here. Okay. Generally, you can see that we have area 5.1. Start with the area. So how we use the area, how to deal with the area, what's the area, and why we are talking about area here. What's the relation between area and the integral? At the beginning, you know, before, if you want to find the area of a triangle, you can rectangle, anything that you can see here. You can see this shape is easy to find, right? You have a width, you have a length, you can say you want to multiply this L multiply by am I right? For the area. How about, for example, if I have a triangle, you know, you say area is equal to 1/2 of the base multiplied by the height. Here's the base. Okay. So the area of the regular shape is easy. You can find it by the rule, right? By the formula. But how about the shape of the area of something like the area like that? I have a suspect like that. Can you imagine the area of the Can you tell me? Find this area. It's not easy. It's not like a circle. Maybe the area is like we have something like so it's not like a circle to find it. It's not a circle. So for that purpose, we need what? We need such idea, right? The idea was like that. We deal with that area like a function. Say we have a function. Here we are. Here's the function. And here's the curve. So I'm going to find the area under this curve. From A to B. We need the area under the curve. We need this area. So how do we find that? So the answer you can find the new chapter or the link in any books that they are talking about the application of integral and they mention the area. So we use the integral. So at the beginning, before they are doing something like that, before they are going to find the area, they try to make a partition. What do you know partition? For example, I'm going to make this area here like 2 parts, 3 parts, 4 parts, depending on my accuracy, depending on my time and work. So if they want to find the area and the beginning, they try to make this area to the rectangle. You can see it's a rectangle 1, A1, right? A2, and A3 instead of the area. Okay, so then later they try to do that on how. Yes, they try to deal with that area, but you can see if I find the area of these 3 rectangles is equal to my actual area. No, there's a mistake, right? There's an error. You can see from the graph, there's an error. Here's the error. Okay, here's the error. Here's the error. Here's the error. Am I right?
So to decrease this error, to control this error, they try to do what? They try to do more partition like that. Here, I'm going to erase all these subjects. I'm going to find the area. Nice. I'm going to okay, to make more partition. Look at here, look at here, look at here. So I'm going to change this A1, A2 to maybe A6. I don't know. Maybe till A6. Okay. So I should erase that one. Now look at the rate of area, rate of the error. I'm going to decrease it. So here's the area. Here's that one, that one, that one, that one. The error a little bit decreased, right? So if I go to part that one, to separate that one again. If I go to touch that one again, look at it. I will increase the area instead of that and change it to the field. Can you imagine? So by partition, by partition, by partition. I don't say it's an actual area, but it's close to it, right? It's close to it. You can cover all this one by these triangles. Sorry, rectangles. So that's why we use that idea to find a bit of large area after separating under the curve or partitioning under the curve to many times. So at the beginning, instead of what do you say? Instead of finding actual area, they say we are going to count all these A1, A2, all these A. Look at it, that's A1, A2, A3, A4, I don't know how much, AN, AN, I don't know. Okay, so they see we are going to sum or add. This is the symbol of the addition or add. Okay, we are going to add all areas that we have from 1 to, for example, 10. We are going to add all these areas together. Was equal to A1 plus A2 till 18. Understood, yes? So if I add all this area, actually close to my area. So if you wanna, because we have approximation, you know, you can use the idea of the limit. We can use the idea of the limit. Like I go to infinity because I want a more partition to less error for AI. And maybe I get my area, maybe. Not 100%, but 99.9. Understood? So all these partitions, all these symbols, all these things that you have today change to from A to B. See, all these rules that we have, all this work change to from A to B because we have A. You can see we have A and B. So I see it's going to be A to B. This function that I have, the curve we have, this function f of x from A to B of a dx. What do you mean by dx? I mean the change over x-axis, the change here. Understood? That's all that we need to know. So in terms of the boundary, it's from the beginning to the end, so the boundary and the name of the man who found these subjects is Riemann. So we have a Riemann integral. Sometimes you hear about Riemann integral. And you can see all these speeds that I said about the area. You can see here, there's a partition that we talked about. And also we have what? We have the sigma addition. Sorry. And also we have what? We have how to add these summation and how to deal with all these part by part as rule that we don't need it. Okay, this one also is also like information background for you that include two exams. Also what? Also the name of the man, Riemann, as I mentioned. Sorry. Okay, you can see the Riemann name. Here's Riemann. Okay. Also, we have what? We have such area under the x-axis. You can see here also above the x-axis. So be careful. This value will give me the positive value, and that one will give the negative value. Understood here? So careful. Maybe later we need this information. That was very important. And you can see here the definite integral. We talk about definite. Definite means that we have a to b f of x. Means that we have a number. You know, you saw this, right? That's not indefinite, that's not definite. Understood? So we have boundary or we haven't boundary. That's all about how to deal with upper limit, lower limit, and the function, the axis that we are dealing with the variable. So here is this information for you, or like an idea, like an introduction to this chapter. You have a question. Some question? Yes. Of course, we have many examples. Okay. Any question about the history, about how to deal? So now we have total area. We have total area. Now we are going to talk about how to find the area. We see it as a theoretical, right? So how to find it, how we deal with it, how is going on, how is the change. If I have a negative, how to deal with it. I have a positive, how to deal with it. That's the today that I'm going to mention. Now I'm going to start with the first example. It's example number 6 here. You can see he say what? He say find what? Find the area of this one on this interval. So I have the function f of x is equal to 4 minus x squared. Okay, on where? On -2 and 2. You know about the graph of this function. Even we don't need the graph of this, but you know, right? You know how to sketch it. Just for your information, for remembering. Here you are. Here's your graph. It's like that. Am I right? X squared is like that, and after minusing, it will be like a complete down. So we have 2, and we have minus. And the question is one, find this area. Understood? Find this area. So I don't need here, because I need here. That's my area. In that case, because the boundary, I have boundary, so I have -2 to 2. I say 4 minus x squared dx. Understood? Because I want the formula. Here's the boundary, low boundary. How many students have seen the integral before or solved the example before? High school. 1, 2, 3, 4. I know. I just okay. So I'm going to start with it step by step. Listen to me, okay? Like I'm thinking, like I've never seen it before, okay? If you are good, good. If you're not good, this is the thing, okay? Be with me. Look at here. I'll leave that example later. I'm going to solve, okay? Later, I'm going to solve this example. How to deal with the integral? How to solve this? At the beginning, I'm going to solve indefinite integral. How? If I have example number 1, if I have just that one, so it's equal to 1. That's like, before I'm going to solve that again, I'm going to give you another definition of integral. What's the antiderivative? Antiderivative. What do you mean by that? For example, I have y equal to sine of x, right? Derivative is equal to here. Cosine. Are you sure? Are you sure? Good. Cosine. Now, because I see this integral is antiderivative, look at it. I see integral of cosine of x will be, the result will be what? The sine of x plus non-negative. You can see here. That's derivative. I will go to the I'm going to take it. Hello? Understood? No. If I am going to write that, I will go to the door. I want to go back. Line. So going is different. Coming back is they are totally understood. For another example, I'm going to give you another example. So if I have another function, give me another function that you like. Any function. 2x, okay. 2x. The derivative of 2x is equal to what? Just to right? Sorry. Is equal to. Understood? So if I wanna get 2x from 2 from that side, I'm going to say is what? Integral of 2x, sorry, integral of 2, the result will be, sorry, will be 2x. Later we say plus c, okay? Plus c. Understood? Any question? Do you know why use the integral? Just get the idea of maybe you don't know. Go back. That's why each idea here's the how? I know the derivative of y is equal to tan of x will be what? Second square of x. Am I right? If I wanna take the second square of x, yeah, because I see is equal to tan of x. Tan of x plus c. Later I'll tell you what. You got the idea? Here's allow it. Okay. Now
بتخفيف y. Okay. When I connect to the screen, the pen is not working properly. I don't know why. Okay. Okay. Now here we are. So we have what? We have a idea that if I have a derivative, I have an antiderivative. Now we are going to start with the rules. Which rule that we have? The first rule, if you have nothing, just dx. So the result will be what? Will be x plus c. We are going to put x. Okay. So why? Maybe you're asking why? Because I know. If I have y equal to, let me tell you about the idea of c. What's the c? Why we put the c? So if I have y is equal to, for example, x, the other function, x plus 2, the other function, x minus 2. So tell me about the derivative. Equal to all of them 1, 1, 1. Am I right? So all of them are equal to 1. Okay, if I want to get the other side, so I'm going to take an integral, right? So if I take an integral, I'll get what? I'll get just x, right? Just x. How about here? Again x. How about here? Again x. But the original is x? No, x plus 2, x minus 2. That's why we say plus. Maybe c0, maybe c plus number, maybe c minus number. Understood? So this see like a balance to give you the good. Now I'm going to talk about that. Okay. We say that if you have nothing, we just have a function. So I say, for example, I have 2 dx. Because 2 is number, I say is equal to 2 dx, and I know in the first example, integral of dx what? Okay, is just equal to x, right? So I have 2 x plus 3. We got it? Do you have any question about the first step? Easy? Hello? Good morning? Good. Okay. So if I have, for example, minus 5 dx, say what? That's equal to minus 5 x plus 3. Why? This one is going to be out, and I'll get the integral of dx, and I know the integral of dx is equal to x. So minus 5 over 5. Understood? Okay. Now example number 2. As I told you, step by step. I'm not in a hurry because I need your attention. No. So if I have just 1x dx, just 1x, no more things. Just x without any exponent, anything. Just I have x. I see is equal to 1. I say I will add dx. I say I will add this. See here. The power of x is 1. And n equals 1. I have an n. If I have 1, I say 1 plus 1. 1 plus 1 equals 2. And also, is equal to 2. And also, I'm going to divide by 2. So add one exponent, dividing by this number.
Maybe you ask me why. Just let me tell you why. Okay. You got here? Okay. Now, y equal to x squared over 2. So tell me about the derivative. Is equal to what? 2 x over 2 is equal to x. Understood? That's why we add power divided by the new power. So if x is 1, I'm going to add 1 divided by. Understood? Okay, now it's your turn. Can you tell me about if I have x to the power 3 dx, that is the third example, how we solve that one? Yeah, x to the power 4 divide 4. Understood? Understood? So every time we add exponent, listen, by 1. Here's t, okay. Here's x, okay. X to the power what? 3. So I'm going to add 1. 3 plus 1, 4. 4 over 4. You got it or not? Any question? يلا دي قلمنا. Any question, جماعة? Yes. We did it. We make it like that. Okay. We say this one divide by that. That's the rule. Okay. Okay. Now I'm going to mix example 1 and the first example, the third example. If I have, for example, 2, I'll go to the other. If I have 2 x to the power 3 dx, so how is that? The number will come out in my mind, okay? And it will come out. I see what? 2x to the power 3 dx. And I know how to do that. So I have what? X to the power 4 over 4 plus 3. But I don't forget about 2, right? So the number will not make any change. Understood? This is I'm going to multiply. I see going to be over 2 plus easy one, yeah? Yes. C is any constant. After solving any indefinite integrals, we put this. After solving any indefinite integral, any f of x, for example, it is equal to something plus c. C like a balance, just like that. Okay, Kaika? Any question? Okay. Please ask, because later it will be more and more. So ask if you have a question. Any misunderstanding? Good. No. Now I'm going to give you something else. For example, if I have from 0 to 1, okay, x dx. How you solve that? Yes, we have a different. Now we have it. Now we have it. How I solve that? At the beginning, I am going to neglect all. I am going to ignore the boundary. So I say just I'm solving this x like that. In my mind, there is no 0, no 1. So how I solve this? X dx. I say is equal to x squared, right? Plus 2 plus c, am I right? But now, instead of c, I'm going to use something else. I'm going to boundary to put the boundary right. I say from 0 to 2. Any questions for the first? You got it? Instead of c, put something like that. In your book, maybe like that. Like a bracket, anything. It depends. Understood? Now, how we substitute it? how we substitute the value. I say upper value as usual, usually minus lower. This is the rule. Understood? Now I'm going to apply this rule for you. I say x squared instead of x, and I'm going to write just I'm going to write something squared over 2 minus another thing over 2 squared. Why I put that? Because in the up, you can see I have x squared over 2. So x I will leave that one. Something over something over. Upper minus lower. So upper is equal to what? Upper is what? How about lower? 0. So I will get what? Understood? Now I don't have any C because we have a boundary. We have a definite integral. Any question? Now, can you sort of this from minus 2 to 4 minus x squared dx. Let's look at it. And let's look at it. So I say is equal to what? I say is equal to 4. Yeah. Just I have a number. A number I say 2. So I'm going to separate them again. Okay. So 4x minus x squared dx. Understood? You can imagine in your mind because we can separate the zeros over addition and subtraction. That's why we don't like it. So here we are. Any question? So the first integral is equal to what? Huh? 4x. 4x is equal to 4x. That's the minus. For a second. X to the power 3 divide 3. Understood? Correct? Careful. X to the power 3 divide by 3. Shall I say plus C or not? Why? Because you have a boundary. Where's the boundary? Here's the boundary. Am I right? Question? Easy? Understood? Good. Now I'm going to use what? Upward. No. Yes. It's a two integral. If I have one integral, for example, I have that one. Yes, you are right. Okay, and I'll just plus theta. But if I have something like that, this is two functions. Okay, the first that one, the second that. So for the integral of 4 is equal to what? 4x. All right. And I have a minus. The integral of x is equal to what? Square divided by. Exactly. In the case where we have multiplication of the something. But if we need it also, we are not going to ignore it. We will use it. But here you can say that for today. Question. Okay. Now how we substitute it? How we substitute this back? Upper minus lower. But we have two x's. Careful. So here's up. Four minus something cube over 3 minus again 4 minus 3 over 3. Am I right? Okay, the first value should be what? I should put what? 2, 2. Am I right? The second value is what? Minus 2, minus. You got it? These all the functions that I have. So I see upper. This is minus. These all together. Lower. Question? I'm not going to calculate this 2 multiply 4 for you. You know. Maybe. I don't. Question? Understood, Jamaat? Okay. So that's all about our example. That's stop here. Fine. We stop here. See how to try it. So here you see you have what? We have these all together. So how we find it? We have this function. And here the function is 4 minus x cubed. And we got أما function كده فيها x squared plus minus 4. Okay? Understood? إما كان function عن حكي yeah, f of x and g of x. So you have two examples here. We try to solve the f of x and g of x. Look at here. Here we are. We have f of x. So at the beginning, we tried to find the f of x, and the second g of x. You can see here's the g of x. What's the difference between them? Even they look like they look like the same function and the same area. But what's the difference? Can you imagine? Can you tell me? Here we have what? Negative value. How about here? Positive value. What do you mean by negative and positive? The negative is under the x-axis. Negative value for the area. This means that the value under the x-axis are going to be what? Value. You see what I mean? Maybe there's no ellipse. There's no shape. Maybe here we are right. In general, no. Right? Here maybe we are right, but in general, no. So here's the question. Here's the point. If you go negative, try to take absolute value, take it a positive. Understood here? Any question? Okay. So 10 minutes.